In the previous chapter, we calculated revenue using FOX. However, it does not provide us with a very scalable solution. In this chapter, we will convert the FOX into an amdp and calculate the revenue using SQL. The SQL code performed the same calculations as FOX, but with the benefit of it being scalable, and it does not need to be adjusted as often as the FOX code for small changes to application. For example, new account and account groups being added to the mapping table. The SQL will be able to handle these changes as they arise. There are a few steps that needs to be configured in order for the amdp to work, and as usual, the steps are covered in the configuration guide, but I just want to cover the creation of our account determination table. So the account determination table is created in SE11, contains 3 fields: the account assignment, sales org, and GL account, of which account assignments and sales org are keys, and all the fields are typed to an info object. And the entries can be maintained in transaction SM30, and in our case, the entries shows that if there's a non-assigned account assignment, or 1, it maps to a single GL account, and 2 and 3 map to different GL accounts. There are several steps required to create a planning function as an amdp. First, we're going to create the ABAP class and implement the required interfaces and methods. Then we create the planning function type, create a planning function referencing the planning function type and add it to a planning sequence. Create the amdp class and write the implementation of the methods, and then execute the sequence. The planning function will use the volumes data as the starting point for the calculation. The volumes data will be the reference data for the application, and for each of the records, the revenue must be calculated. In order to utilize HANA, we will handle the reference data selection based on the parameters in the planning function type in the SQL class and methods as well. In order to keep the code manageable in this book, we will use simplified SQL statements to select the corresponding prices. First, we need to create our ABAP class ZCL-SL-Rev. This class will be the entry point to our planning function, and we'll call the amdp class to execute the SQL. Now, we've already covered the creation of the class, but let me refresh your memory. We go to our ABAP project, right-click, and say New ABAP class. You'll then be presented with the empty class. And as always, the code to this class is in the manual. The first prerequisite is to implement the interface. And let's go to the interface, right-click, and go to Open with SAP GUI. And double-click. And we can see that the 3 methods that this interface exposed to our class. Now, if we go to the init execution method and click on parameters, we can see that some of the parameters, or 2 parameters, has to do with the filter, and the one that we're interested in is the IT data char cell. This is the selections from our filter, and this is only available in the init execution method. For example, if we go to the execute method, click on parameters, we can see that the filter is not available. So in order to access these values on the filter during my execution, I'll have to load them to a static class attribute, which I declare as class data and type it. And then in my init execution method, I simply assign the import parameter for the filter to my static class attribute. The execute method contains the main logic for the function. We can either implement the whole planning function as ABAP, or if we want to use SQL, call the SQL class. In the first part of this method, we need to read the variable values in the ref data structure as contained in the ref data tab of our planning function type. The next section, we instantiate our amdp class, and since we want to overwrite the data in the DSO with our new calculated revenues, we clear the CTH data table. We then call our amdp method and assign the calculated data to the CTH data table again. The next step is to create the planning function type. The planning function type will allow us to create a custom planning function with the prompts and parameters we need. In our case, we need a function type that contains the selection parameters for the reference data, which is volumes. To create the planning function type, we go to transaction RSPLF1. and we give the function type a name, and in our case it will be the same as the class. And create. We give it a description, which is calculate revenues, and then we assign the class. So in our case it is the same as the name, and as you may recall from earlier chapters, the planning function executes in blocks. Each block calls the code of the planning function. In order to use HANA and SQL to the fullest extent, we need to eliminate multiple calls to our SQL. The SQL must process the full logic of the planning function in a single pass, and looping through the blocks just creates an inefficiency and massive performance penalty that we need to eliminate. For this reason, we will not be using any blocks in our planning function type, so we will check the without blocks. We now move straight into our parameters. First, we create a tabular parameter called ref tab, and this will be our reference table. And the parameter type will be structure. Next, we create another parameter called ref data, which will contain our selections. And the structure parameter will be the ref tab structure we created previously. We will then select the parameter type as data selection, and the characteristic restrictions can either be all characteristics or to be changed characteristics. In our case, we're going to select all characteristics, and since we are not using blocks, it really doesn't matter which one you select because the all characteristics and to be changed characteristics will be the same. And yes, the next step is to activate the planning function type. Now that we have the planning function type, we can create the planning function. So we're going to create planning function TSLP 1004 PFO2, create, and we're going to create the function type, calculate revenues. And our function will be called calculate revenues as well. The first thing that we see is that the fields to be changed is missing because we do not have any block characteristics. Next, we move on to parameters. And here we see the reference data table structure that we created in the planning function type. So under edit, we can go and create our parameters. And there we see all the characteristics that's involved in the cube. So here we can make our selections. The variables in the planning function overlaps those of the filter, as the reference data and target data areas are mostly the same, differing mainly in the info provider used. Another difference between the two is because we're writing to our revenue ADSO and that requires an account, we're hard coding the chart of accounts, while the chart of accounts is not in our source volumes planning ADSO. Now let's look at the progress we've made so far. I'm in transaction SE80 in our class in the execute method, and I've commented out the code for the classes we don't have. So that's the instantiation of the class as well as the method call. Then I've added a breakpoint at our last statement. Now let's go to transaction RS plan and execute our planning sequence. So I've created a new planning sequence. And I'm going to run it with the following variables, so only for 1 month. When I execute, I see that it stops in our class, and if I click on the table tchar cell, we can see that it contains the selection from my planning function. So this will be my reference data. And CT data has been cleared. So we are ready to implement the amdp class and its methods. We are now ready to create our amdp class. So I'm going to go through this step by step. So the first step is to create the class itself. Have a class, and we're going to call this class ZCL SL amdp rev, calculate revenues. And finish. We are then presented with our outline, and the first thing we need to do is to, under the public section, allocate the interface if amdp marker HTB. This will allow us to actually create the amdp and the SQL methods. The next step is to create our data types. And we're going to create a single data type for our export data. Now, how do we know what the export data type looks like? Well, it is the info objects in our aggregation level, but we have to get the sequence right, and it's generally in alphabetical order. I can also verify it by displaying in my debugger. So let me just go back. In my debugger, I can display CTH data and look at the column configuration. And the sequence of these fields must agree to the order of my fields and my data type. And at this point, I can activate. The method declaration is next. And we're going to define a single method, amdp_rev, that imports the reference data selection table defined in our planning function and planning function type. And we're going to export the fields of our aggregation level, so the type that we've just created. Next is the implementation, and as always, the code is in the attached configuration guide. So a detailed description of the various elements of the code can be found in the configuration guide. Now that we've activated our amdp class, we can go back to our ABAP class and either add the lines or uncomment the lines that refers to this amdp class. And that is the definition of the local variable or the local class that references our amdp class, the ET data structure, the instantiation of the class, and the method call, and then finally the assignment of our ET data to the export hash table for the execute method. So once this is done, you can activate the method and we'll execute it in RSPlan. So I'm now in the planning sequence containing our planning function that we just created, and I'm going to execute it for a single period and execute. And we can see that a lot of records were generated, and if I go display, I can see all the new records that has been created. And if I go to the bottom, I can see a change in GL account. So we know that the GL account determination has worked. Now let's look at our progress so far in Eclipse. I'm in a planned revenues query in our planned revenues tab, and I've created a button to actually plan the revenues. So I'm going to execute our planning sequence. And once it's completed, as soon as I save the data, we can now see the data. So against my material group, in this case, you can see the split between accounts. And if I drag in customer, for example, we can see that the revenue has been calculated on the detailed level. Now let's verify our results. So I'm in my query, and I'm going to drag in my material because we want the detailed record. And then we're going to manually calculate. And of course, you can create a query that does this as well, but I want to illustrate the principles. The price by dividing the revenue by the planned volumes for that material. So TG11, customer 10. And we see a price of 125. And if I do the same for customer 1710, I get a price of about 99. So if I round them up, we can see 125 and 99. Now, if I look at my prices, first we see if there's a price by customer material group. And we can see that there's no price for 101 and 10 and 1. So the price of 99. And if I go to my planned revenues, we can see 99. And if I go to my prices by material group, we can then see for L1, the price is defaulted to 125. So we can see that the price has been correctly determined using our sequence. In this chapter, we implemented an amdp class to calculate revenue. Reference data from an ADSO not in the composite provider was used, as well as lookup data from a Z table. Implementing custom functions allows with many additional options. Not only does it allow us to create calculations within planning functions, but we can also call BAPIs to write information back to ERP, and call HANA Predictive Analytics library functions. We now have met all the requirements for the planning application. In the next section, we will look at some of the administration functions available in Embedded. During any planning process, planning data must be protected against changes, especially once a plan has been approved. Data slices provide the mechanism to enable this locking and can either be manually set based on an exit variable or set through an exit class specifically for data slices. In our case, we're going to configure a process whereby the planning administrator can set the data region to be locked via a query, and upon saving, an exit class will set the data slice parameters for the info provider. We will lock the volumes planning ADSO TVOL 820 by version and sales organization. The steps required to create data slices based on an input-ready query is as follows. Create the input-ready query and related objects, create the ABAP class to process the data slices, and then configure the data slices. We will then create an amdp class to process data slices as an improvement over the ABAP implementation. Before we start with the configuration, let's see where we're heading.